Let's move across as we do this problem. So we'll do the top half and then we'll do the bottom half. So first, what's the particle's position when t equals 0? Well, we just have to plug it in, and that's obviously going to be 4. Same thing for when t is equal to 3. We just find x of 3, plug it in, and that'll obviously be 22. For part B, we want to find the average velocity over the first 3 seconds. So this is really the most important word here, average. When we see average, what we're going to want to do is just find the slope. So we'll go x of 3 minus x of 0 over 3 minus 0. In this case, that's 22 minus 4 over 3. So 18 over 3 is just 6. It's in the next one where we want to find the instantaneous velocity. When it's instantaneous velocity, that's going to mean that we have to find the derivative. So the velocity is going to be the derivative of the position. So in this case, that'll be 3t squared minus 3. But we want to find the velocity when the time is 2. So just plug 2 in there, and you'll get 12 minus 3, which is 9. Now, when is it stopped? Well, it's going to be stopped when the velocity is equal to 0. So just take that velocity function, 3t squared minus 3, set it equals 0. That'll give us t squared equals 1, so t is equal to plus or minus 1. Now we want to know when is it stopped on the interval from 0 to 3. Well, negative 1 isn't on that interval, so our answer is just going to be when t is equal to positive 1. In part E, we want to know when is the instantaneous velocity equal to the average velocity. So we're using both of these words in the same problem. Well, remember the instantaneous velocity, that's the derivative, the 3t squared minus 3. I want to know when is that equal to the average velocity, the 6. So we have an equation, just start solving it. And once again, we have to worry about that it says, when are they equal on this interval from 0 to 3? Well, the only one of these answers that's between 0 and 3 is the positive one when t is equal to the square root of 3. Lastly, I want to know what is the acceleration when t equals 1. Well, remember that acceleration is going to be the derivative of velocity. So we just take that velocity function we have and find its derivative, 6t. Now we can plug in 1 because I want to know what's the acceleration at 1, and that's just going to be 6. And then we're done.